Hello, pre-calc students, especially my seniors. This is where we left off on our notes for today. We were talking about evaluating limits, especially when there can be some issues. We started talking about square roots, and we talked about there was a transformation to the right 4, and that's where the new anchor point was. And when that happens, when I'm asking for the limit as x approaches 4 in number 3, since that is the anchor point and that's where the graph starts, the graph doesn't exist from the left, and then the graph does exist from the right. And as you can see, we properly wrote out notation from the left and from the right. And since they don't approach the same limit, then therefore the limit should be does not exist. So I'm going to take you through the other scenarios as well. So for number 4, and this is where we left off, we're going to look at the limit as x approaches pi over 2. Now, if you think about it, pi over 2, right? If we think about the unit circle, and of course this is from semester 1, I'm just going to quickly draw unit circle over here. There was 0, pi over 2 is up here, and the coordinates was 0, 1 up here at the top. And of course, tangent is y over x. So if you take 1 divided by 0, that would be undefined. So if you try to take the tangent of pi over 2, the tangent of pi over 2 is actually undefined. And if you look at the graph, if you're more of a visual person, there's a vertical asymptote when you graphed it out. So if we graph this off to the side here, just a little more space off to the side. So number 4, let's graph this. So we have our asymptote that this was at pi over 4, this is at pi over 2, and of course we have our vertical asymptote, negative pi over 4, and then negative pi over 2. And we had our vertical asymptotes. Now this is back from semester 1, but this is what the tangent graph looks like. Okay, and then we have our graph, it comes through, it looks like this. And then if you repeat the pattern, right, it will come this way, and there we are. So I did that in orange off to the side so you can see the graph properly. And of course they're asking for the limit as x approaches pi over 2, which of course we know is undefined, so there's a vertical asymptote right there at pi over 2. Now, the limit as you approach pi over 2 from the right, if you look up, and I'm highlighting this in green, it would approach positive infinity. So if we use proper notation, we would say the limit as x approaches pi over 2 from the left of the tangent of x, okay, that would be infinity. Okay, and then over here, as we approach pi over 2 from the right, and I'm highlighting this in pink, we're going down to a negative infinity. So the limit as x approaches pi over 2 from the right of this graph, it would be negative infinity. So since the limit from the left and the limit from the right, of course, don't match, one's going to infinity, one's going to negative infinity, we're going to have an overall does not exist limit. Okay, so we'd have to watch out for those vertical asymptotes. Okay, so if this is making sense to you and you feel confident enough to try one, I would try number 5 because that's what we did in class. So try to think about the secant graph. You can use Desmos and open up Desmos, type in the secant graph if you're not recalling straight away. And then see about the limit there. Try to write out the limit from the left and from the right and see what we get. Okay. If you would like to follow along now, or if you just unpaused and you were trying it on your own, let's go over number 5. So number 5 here, I'm going to graph off to the side so you guys can see it. So secant of x, this guy, if you again look at, now it's asking for the limit as x approaches pi over 2. If you look at the coordinates up here from number 4 on the unit circle, the coordinates at pi over 2 are 0, 1. And the secant is 1 over cosine, which is 1 over x. So 1 over 0 would be just undefined again. So if you think about it, if you were to actually try to evaluate, the secant of pi over 2 is actually undefined as well, just like what tangent. So therefore, we're going to get a vertical asymptote at pi over 2. And if you're more visual and you want to see the graph, you could quickly graph this out. This would be at pi over 2, then pi, 3 pi over 2, 2 pi. And then remember when we were graphing secant, we just graphed the cosine graph, right? And then we use that as a starting off point. Okay, so then we have the secant graph go here, the vertical asymptotes, where anytime we're going through the x-axis because 1 over 0 is, of course, undefined. And then we have our graph coming down here and going up here. And again, you can use Desmos if you wanted to see as well. Okay, so of course we're looking as x approaches pi over 2, which again looks to me like those limits are not going to match. So if we look at the limit from the left, it as well is going up. So the limit as x approaches pi over 2 from the left of secant of x would also be infinity as well. And then the limit as x approaches pi over 2 from the right is going down. So the limit as x approaches pi over 2 from the right is negative infinity, just like with the tangent graph. Since they are approaching different values, our overall limit should be does not exist. Okay, so with those vertical asymptotes, you do have to watch those. Now, if they were both approaching infinity, then it would overall be infinity, or if they were both approaching negative infinity. So you have to watch out for that as well. But in this case, for the tangent and the secant graphs, they're approaching different values, so does not exist for the limit. Okay, let's take a look at another scenario. So we've actually seen piecewise functions a lot. You saw it in the warm-ups, you saw it with the notes, you even saw it with the homework. So piecewise functions have been all over the place. They're notorious for having different limits because there's different functions, of course. It's just a chopped up graph. So let's take a look. So when you have a situation where x is approaching 1, and I like to call this the changing of the guard over here because this is where the domains are switching from one function to another function. So there is a large probability that we are going to get some sort of jump in the graph and it's going to be approaching different values. So we're going to have a does not exist situation. However, there are some times where you have a piecewise function where it's continuous in the fact that, you have a bunch of closed circles and the one function picks up where the other function left off. And we've seen that, but it doesn't happen all the time. So how do you find out? How do you check? So what I would do is I would plug in 1 for the top function. So for the top function, plug in 1. So you're going to have 3 times 1 minus 4. And it looks like here we're going to get negative 1. Okay, now let's look at the bottom function. Let's plug in 1. So we're going to see 3 times 1 plus 4 equals 7. Those two values are different. You'd have an open circle at when y is 1, negative 1, and then you have a closed circle at 7. So therefore, the limits from the left and the limit from the right would be approaching different values again. So actually, you'd write it like this. The limit as x approaches 1 from the left, okay? And that would be negative 1. And then the limit as x approaches 1 from the right of that function would be 7. And since they're approaching different values, the overall limit does not exist. Okay, and you'd have to show all that work. You'd have to show the left side limit and the right side limit as well. Okay, the last curious case I'm going to show you is rational functions. For this one, what you have to look out for is rational functions. Where are they undefined? It's when the denominator is 0, and that's usually where we get our vertical asymptotes. Now look here, x is approaching negative 6. If you plugged in negative 6 into the denominator, we get 0, and then we get undefined, okay? And of course, then we get a vertical asymptote. Now, if we get a vertical asymptote, the limit may still exist if both the limit from the left and the right are both approaching infinity, or if they're both approaching negative infinity. But if they're going in different directions, like one's going to infinity, one's going to negative infinity, just like number 4 and number 5 for the tangent and the secant graphs, then it would be does not exist. But there's also a very sneaky situation that happened, if you were paying attention to when we were going over our mini test, is that sometimes there's a hole, and you don't know there's a hole until you fully factor this guy out. So when you're factoring out rational functions, please make sure to copy down the limit notation again. If you're planning on taking AP Calc, on the AP test, you would actually lose points for dropping the limit notation. So here we are, we'd have to fully factor out x plus 5. This guy is x plus 6 over the x plus 6, and oops, there it is. There's the hole. Okay, and when you have a hole in your rational function, holes are okay. I mean, it's undefined, of course, at that point, but the limit from the left and the limit from the right are approaching the same y value, which is the y coordinate of the hole. So holes are fine. We can actually have the limit. The limit can exist. So holes are okay. We like those. So to find out the y coordinate of the hole is what we did back when we were taking our mini test. We just plug in -6 into what's left of the function. So what's left of the function is right here. So we're just plugging in the x value at -6, and we're going to evaluate, and we get -1. So the limit is -1. So holes are okay. Vertical asymptotes, you got to check those. They might be going in different directions and it does not exist, or they both might be approaching infinity or negative infinity. Then it's one or the other. So those are all the different cases where you can have a does not exist situation, or you got to just double check the limit and they're just not straightforward. Please replay the video if you need to. Otherwise, that takes care of the notes for today.